Namaste. Today in this video we are going to discuss about types of learning. Okay, in previous video we have discussed about learning by analogy. Now let us discuss about another types of learning, that is the second one was rote learning. Okay, so rote learning avoids understanding the inner complexity but focuses on memorizing the material so that it can be recalled by the learner exactly the way it was read or heard. Learning by memorizing avoids understanding inner complexities in the subject that is being learned. Rote learning instead focuses on memorizing the material so that it can be recalled by the learner exactly the way it was read or heard. Learning sometimes be repetitive over and over again, saying and trying to remember how to say it. It does not help us to understand. It helps us to remember, like we learn a poem or a song or something like the repeating the multiplication table of mathematics is example of rote learning. Okay, so next is learning by example, or it is also known as inductive learning. Okay, so process of learning by example, where system tries to induce a general rules from set of observed instances. The learning method extract rules and pattern out of massive data set. The learning process begin to supervised learning. Okay, does classification and construct class definition called induction or concept learning. Let us consider that we are trying to learn Boolean function, that is all input and output are binary. Yes, so example, there are 2 power d possible ways to write d binary values, and so with d inputs the training set almost have 2 power d instant, where each of these instant can be labeled as 0 or 1. Therefore, there are 2 power 2d possible Boolean function of d input. Each distinct training example removes half of hypothesis, namely those where guesses are wrong, for example, so it interrupts inductive learning. If training set given contains only a small part of all possible instances, at it generally does, then the solution is not unique. After seeing an example, there remain 2 power 2d minus n position functions. The example of ill-posed problem where the data by itself is not sufficient to find a unique solution. So, unless the possible instant of data by itself is not sufficient for inductive learning to find unique solution with data given. The assumption which are made to be have learning possible is called inductive bias learning algorithm. That includes set of assumptions and the true function which are to be notified or modified as given. It defines the set of hypotheses that a learning algorithm has. Consider when it is learning and guides to learn algorithm to prefer one hypothesis over other is a necessary prerequisite for learning to happen, because inductive learning is a ill-posed problem. So let us discuss about inductive bias learning algorithm. Okay, So inductive bias learning. Okay, the set of assumptions that the learner used to predict output of a given input that it has not encountered is expressed by using inductive bias learning. In machine learning, aim is to construct algorithms that are able to learn to predict a certain target outputs. To achieve this, the learning algorithm is presented some training example that demonstrate the unintended relation of input and output values. Then the learner is supposed to approximate the correct output, even for example that have not shown during training without any additional. This cannot be solved exactly since unseen might have arbitrary output values. The kind of necessary assumption about the nature of target function are subsumed in the phrase inductive bias. Okay, and we use training examples in inductive bias learning. Let us consider an example, okay, razor problem, which is the principle of parsimony or economy used in logic and problem solving. It states that among competing hypotheses with the fewest assumptions should be selected. Razor states that one should proceed to similar theories until simplicity can be traded for greater exploratory power. The simplest available theory need to be more accurate, assuming that the simplest consistent hypothesis about the target function is actually the best. Here, consistent means the hypothesis learned yields the correct output for the example that are given. Okay, so the example may be maximum conditional independence, and next may be maximum description length, third one may be maximum cross validation error, and last one may be minimum features. So next type of learning is explanation based learning. Okay, it is also termed as EBL. Sorry. Human appears to learn quite a lot from examples and is accomplished by examining particular situation or condition and relating them to the background knowledge in the form of non-general principle. This method of learning is called EBL, okay, explanation based learning. So explanation based learning is abstracting a general concept from a particular training example, and is also a method to define general conception on the basis of specific training example. It analyzes the specific training example in terms of domain knowledge and good concept. That result is an explanation structure which elaborates why the training example is accounted for good concept, and the explanation structure is used as basis for generating general concepts. So its architecture can be given as, okay, input. So we have specific goal problem, specific goal problem, and the problem solver solves the problem. That means problem solver, and it helps in explanation. Okay, so generator So it has knowledge base or knowledge box and new general concept. That means by seeing the solution of all problem, the new explanation can be generated, or by the explanation of all problem, the new general concept can be generated. That is how the machine can learn. So next one is its semantic, okay, system semantic, explanation based learning semantic. Domain theory, okay, training example, and here is problem solver, so goal concept, it helps in generalization, okay, and it helps in operation pruner, and it gives outcome. Okay, so this is the AVL semantic. Now let us discuss about next type of learning. So next one is learning from the advice of order. So by the topic it says yes. So basically it includes the similar feature of learning by analogy, the similar feature of learning by analogy and learning by example. And the different is that there may or may not be presence of guidance to perform the learning activities. It can be supervised or unsupervised learning. Okay, so learning from the advice of order can be supervised or unsupervised learning. So supervised learning, okay, and next one is unsupervised learning. So we'll be discussing supervised and unsupervised learning in neural network also. So I'll be discussing a short introduction in this too. Okay, so supervised learning, it is the learning process which consists of the information about the input to be provided, that is data and output to be accounted in the supervision of an advisor or supervisor. This type of learning is basically performed to develop complex system. In this method, the model defines the effect on set of observation called inputs, has another set of observation called output. It includes mediating variables between the input and output. It is one that tries to find a connection between two sets of observation, which increase learning tasks difficult and increase exponentially in the number of steps between the two sets. Okay, and next type of learning from the advice of order is unsupervised learning. It is in this approach, all observations are assumed to be caused by latent variable. That is, the observations are assumed to be at the end of the causal chain. It is not needed as long as input are available. But if some input values are missing, it is not possible to inform anything about the outputs. So next, last one was reinforcement learning. Yes, so it allows machine and software agent to automatically determine the ideal behavior within a specific context in order to maximize its performance. Simple reward feedback is required for the agent to learn its behavior. This is called reinforcement signal. It helps the machine agent to learn its behavior based on feedback from environment, which can be learned one and for all or keep adapting as time goes by. If the problems are handled with care, it can cover to global optimum, which maximize reward. Yes, so reinforcement learning, we can give the example that in child age, for getting a toffee, we do our homework. Yes, that is reinforcement learning. For doing something, we get a reward. If we do not do homework, then teacher will beat us or provide punishment. That is reinforcement learning. For something, doing work, we get award. Yes, that is reinforcement learning. So this is the end of machine learning. Okay, and in next video we'll be discussing about reasoning. Thank you and bye bye.